Welcome to this explainer. Today, we're going to build a highly structured, bulletproof mental model for passing the CISSP exam. Think of me as your expert instructional guide through the critical concepts of Domain 6 and 7, disaster recovery planning and operations. We aren't just going to memorize facts today. We're going to learn how to think exactly like the exam creators. We're breaking down the technical realities, the strategic business decisions, and most importantly, the traps you absolutely need to avoid. Okay, let's take a quick look at the agenda so you know exactly what we're conquering today. We're covering the nature of disasters, system resilience and RAID, recovery site strategies, database and data backups, and finally, DRP testing and maintenance. Let's jump right in. Section 1. The nature of disasters. So, before we even think about building a recovery plan, we've got to establish our specific threats. Take a look at this U.S. Geological Survey's seismic hazard map. You know, you might assume a state known for earthquakes just has a uniform risk profile, but this map shows highly localized, granular risk pockets. For the exam, you have to remember that localized risk assessment is a mandatory due diligence step in your business impact analysis. You simply cannot plan effectively without granular data. Now, these threats basically divide cleanly into two main categories. On one side, natural disasters bring physical fury. Things totally beyond human control like floods, storms, and pandemics, which pose safety risks and prevent gatherings. Then on the other side, human-made disasters often exploit our complex dependencies on technology and logistics. Think about cascading power grid failures, malicious acts like terrorism, or a critical software bug that just crashes your entire infrastructure. Your plan has to account for both the raw fury of nature and the fragility of our own systems. Here's a really critical exam mindset note. You need to know the exact boundary between two concepts that get confused all the time. Business continuity planning, or BCP, handles the overarching business survival processes, but disaster recovery planning, or DRP, is the technical complement. Literally, the minute IT becomes unable to support mission-critical processes, the DRP kicks in to get servers, networks, and databases back online. Do not blur these lines on the test. Moving on to Section 2, System Resilience and RAID. All right, stepping into proactive defense, our main goal here is availability. And the ultimate enemy of system resilience is the single point of failure, or SOF. If a database relies on just one hard drive and that drive dies, well, the whole system dies. As a security professional, you must hunt down and eliminate any SOF. We do this by implementing redundancy, like failover clusters or dual power supplies, and fault tolerance, which allows a system to take a localized hit but just keep operating seamlessly. You've got to memorize this table for the exam. You need to instantly distinguish between these concepts. RAID 0 is striping for pure speed, but zero safety. If one disk dies, it's all gone. RAID 1 is mirroring for safety, keeping an exact duplicate on a second disk. RAID 5 introduces parity, mathematically reconstructing data if one disk fails, and that requires a minimum of 3 disks. RAID 6 goes a step further with dual parity, surviving 2 disk failures. And RAID 10 combines striping and mirroring for speed and really robust fault tolerance. Now, this proactive defense ties directly into the concept of trusted recovery. Basically, when a system crashes, how does it wake up? You have to decide if confidentiality or availability is more important during a disruption. A fail-secure system prioritizes confidentiality. It locks down and blocks all access when it breaks. A fail-open system, on the other hand, prioritizes availability. If a physical electronic door lock loses power, it pops open so people can escape safely. You must align this choice with your specific business requirements. Here is another huge CISSP exam mindset note. Do not fall for the exam trap, where a scenario describes management claiming a RAID array replaces the need for backups. RAID protects against hardware failure. It absolutely cannot save you if an administrator accidentally deletes a mission-critical database, or if ransomware encrypts the entire array. Fault tolerance keeps you running. Backups let you go back in time. They are definitely not the same thing. Section 3. Recovery Site Strategies. When your primary site gets destroyed, picking the right alternate facility is absolutely vital. You've got to align your recovery time objective, or RTO, with the appropriate site. A cold site is cheap. It's just an empty building with power, but it takes weeks to bring in hardware and actually restore data. A warm site has the hardware ready, but you still need to load your data backups, which might take 12 to 24 hours. Then there's the hot site. It's an exact live replica of your primary site. It cuts over in seconds, but you're going to pay double your IT budget to maintain it. Let's pause for a second and think like an examiner regarding mutual assistance agreements, or MAAs. This is where two companies sign a contract promising to share space and resources if one of them suffers a disaster. Sounds incredibly cost-effective, right? But what's the hidden trap here?
Exactly. The exam wants you to recognize the operational and legal realities of M&As. First off, they are notoriously difficult to enforce legally when push comes to shove. If the other company's leadership suddenly decides they don't have the capacity for you, you're out of luck. Second, the proximity vulnerability is huge. If a hurricane wipes out your city, it probably wiped out your partner's facility right down the street too. Plus, mixing two companies' networks creates massive confidentiality concerns. They are just terrible primary recovery solutions.
Section 4. Database and data backups.
So now we need to capture the data for those alternate sites. When evaluating backup types, I want you to focus intensely on how they handle the archive bit, because the exam heavily tests your technical understanding here. A full backup captures everything and clears the archive bit. An incremental backup captures only what changed since the last backup of any kind, and it also clears the bit. But a differential backup captures everything changed since the last full backup, and crucially, it does not clear the bit. Let's look at a scenario to see exactly why that archive bit dictates your recovery time. If your system crashes on a Saturday and you use a differential backup strategy, it's a really simple two-step process. Restore Monday's full backup, then restore Friday's differential backup. Boom, you're done. If you used incremental backups, you'd have to restore Monday's full backup, then Tuesday's tape, Wednesday's tape, Thursday's tape, and Friday's tape in exact chronological order. Differential takes a bit longer to write every night, but it is vastly faster to restore in an emergency. For heavy-duty database recovery, you essentially have three main tools, and you must scale your choice to your budget and time constraints. Electronic vaulting is just the bulk transfer of large backup files to a remote site. Remote journaling is faster. It frequently transfers the actual database transaction logs to a remote location. And remote mirroring is the ultimate solution, maintaining a live, real-time replica of the database at an alternate site, ready to take over instantly. Ultimately, you must strictly align these technical choices with your business thresholds. The maximum tolerable downtime, or MTD, is the absolute longest a business can survive being down. Your recovery point objective, or RPO, determines how much data loss you can tolerate. So, if the business demands an RPO of 0 data loss and an RTO of 5 minutes, you can't just choose cheap electronic vaulting. Only remote mirroring will legally and contractually fulfill that requirement. Finally, Section 5. DRP testing and maintenance. Look, a disaster recovery plan is literally nothing but a false sense of security in a 3-ring binder until it is rigorously validated. Testing follows a very strict, graduated progression. You start with a read-through, which is just a paper review. Then a walkthrough, basically a tabletop exercise in a conference room. A simulation adds non-critical interruptions to see how people react. A parallel test brings the alternate site online while leaving the primary running, and finally, the full interruption test. You must never attempt a full interruption test before successfully passing all previous less disruptive stages.
Now, the exam will definitely try to blur the lines between those last two steps. Remember that a parallel test gives you the confidence that the alternate site works without risking the business, because the primary site stays online. A full interruption test literally pulls the plug on your primary operations. It is highly resisted by management because the act of failing over and then returning to the primary site afterward, which is often called salvage, is an incredibly risky activity in itself.
I'm going to leave you with this final challenge as you prepare for the CISSP. Apply these strict definitions to your own systems. Look at your backups, your RAID arrays, your site contracts, and your testing schedule. Make sure your resilience is real, tested, and aligned with business objectives, not just theoretical. Thanks for joining me on this explainer, and keep studying with that focused, critical exam mindset.